Mr. Coyle here for Coyle Maths. Today we're going to go through a last-minute National 5 Maths 2024 exam paper, courtesy of Chris Smith again. This is the calculator version. Link in the description where you can get it at clyonmaths.com. Let's go. Okay, question 1. 97,732 Scotland fans have booked flights for the Euros. If this increases by 8.1% for the next 3 months, how many fans will go to Germany in June? So we've got 97,732, and this is an appreciation question. So 8.1%, so I want to do 100 plus 8.1 to get 108.1, and then I immediately divide that by 100 to get it into a decimal multiplier, which is 1.081. So I need to times by 1.081, and the power is 3 because it's 3 months. All of that's getting done in a calculator. 97732 times 1.081 to the power of 3. I'm going to write my unrounded answer first. That gives me 123,456.473. But this is people, so how many fans? The total answer has to be 123,456 because you can't have that bit of a fan. So I'm going to do this whole number. Okay, last minute 2024 National 5 Maths exam question 2. Factorise fully both of these expressions. So part A, always look for a common factor first. Now 5 does go into this, so I take out that and I've got a squared minus 5 into 8 goes 1, 3 left over, and 5 sixes is 30. So you get that, and now you see if that can be factorised. Well, that's a difference of 2 squares, so I can write a and a. Square root of 16 is 4, 4 and 4, plus in one bracket and minus in the other, and we're done there. Part B, factorise 2b squared plus 13b plus 15. There's lots of ways to do this. You can do it just by trial and inspection and just see if you can get the answer. But the way I'm going to do it is check for a common factor. If it isn't, I times the 2 and the 15 together. And that gives me 30. So I'm looking for 2 numbers at times to make 30. The middle number is 13. And I'm just going to split the middle term, basically. So numbers at times to make 30. Well, I've got 1 and 30, 2 and 15, 3 and 10, 5 and 6. And I want to pick the pair that when I add them together, I get the answer 13. Now they have to be added because the last number's positive. So 1 and 30 doesn't work, 2 and 15 doesn't work. I could do 15 take away 2, but that'll give me minus 30. 10 and 3, that works, and that one doesn't. So I'm just going to write plus 10 plus 3. So now I split my question up into 2b squared plus 10b plus 3b plus 15. And you can factorise each of these 2 terms individually. So taking 2 out as a common factor and a b, I get b plus 5. I just make sure my next half has also got b plus 5 in it, making sure it's exactly the same. And then I just work backwards. Well, 3 times b is 3b, and it's a plus. And now it's basically factorised. Double brackets now. I've got b plus 5 and 1, and the other one's going to be what's outside, which is 2b plus 3, and we're done there. Question 3. Solve 5 tan x plus 4 equals 3 between 0 and 360. So this is a trig equation. So let's start off 5 tan x degrees equals, well, 3 take away 4 is minus 1. So that means that tan x degrees is minus a fifth. And now I need to do the inverse tan. So I do the inverse tan of not minus a fifth, but a fifth, because the cast diagram I'm going to use only works on positive answers. So let's just get my calculator. Shift tan, open bracket 1 over 5, is 11.3 degrees. So now I can get a cast diagram. Hopefully you all know how these work, but I'll briefly go through it. Essentially, I'd usually tick A and T if tan was positive, but since it's negative, I pick the other 2, which is S and C. With this one, I do 180 minus the angle. This one will be 180 plus, and this one's 360 minus. 2 answers, you get x equals 180 minus 11.3, and x equals, from the C, 360 minus 11.3. So that's 168.7 for first one. And the second one 348.7. And we're done there. Question 4, vectors. So let's have a look, see what we've got. Right in the coordinates of C, D, and E. C, D, and E. So we've got a square-based, well, is it a square-based pyramid? We've got a pyramid. Is it trying to trick us? So it goes 8, 9, 10, 11. So that'll be 12, 13, 14. So this length here will be 6. But going in the way, we're starting at 8 and we're ending at, in the way we're starting at 0, and then the middle is 2, and then out 2 again is 4. So it's actually not a square-based pyramid, so be very careful, it's 6 by 4. So to get C, I go along 8, 9, 10, 11, 12, 13, 14, and then I don't move, so it's 14, 0, 0. To get D, I need to go along the 14, and then I need to go in the 4, and then don't move, so it's 14, 4, 0. And then to get E, I need to go along to 8, into 4, then don't move, so it's 8, 4, 0, and we're done there. Question 5, simplify this. So we've got an algebraic fraction. I can do a common denominator, 5 times 7, that's 35. And then I'm just doing 2x times 7. 7 times 2x is 14x, minus 5 times x plus 1. So I'll put that in brackets. And then we can just expand the bracket and simplify. That's 14x minus 5x minus 5 all over 35. 14 minus 5 is 9, so you get 9x minus 5 over 35, and we're done there because there's no common factor on the top to simplify it further. Last minute National 5 Maths 2024 question 6. A single dust particle weighs 7 times 10 to the minus 10 kilograms. How many dust particles are there in a pile of dust that weighs 6.3 kilograms? So let's just puzzle this one out. One particle equals 7 times 10 to the minus 10 kilograms. And I want to work out how many dust particles are on a pile of dust that weighs 6.3 kilograms. So this side becomes 6.3 kilograms. So we're basically trying to work out how do we go from this number to this number? What do we need to times by? Now to work that out, if I do 6.3 and divide by this number, that'll be my multiplier. So that's what I'm going to do. So the answer is 6.3 divided by 7 times 10 to the minus 10. And you get 9 times 10 to the 9. And we're done there. Let's just double check that. That means that to go from here to here, I do 7 exponential minus 10, and I times by 9 exponential 9, and you get 6.3, so it is correct. So we're done there. Change the subject to r. So I've got y equals mr squared plus s. So first of all, take away s. Y minus s is mr squared. Divide through by m. Y minus s over m equals r squared. And the opposite of squared is square root. So the square root of y minus s over m equals r. Or to write it as r equals the square root of y minus s over m. And we're done there. Question 8. Write x squared minus 4x plus 8 in the form x plus p squared plus q. So that's called completing the square. So what I do is I half the middle term, so it's x, it's still minus, but it becomes 2 squared. And you immediately take away that number squared, the 2. So take away 2 squared, or take away 4 in other words, but we have still got plus 8 on the end. So that gives me x minus 2 all squared, minus 4 plus 8, which is x minus 2 all squared. 8 minus 4 is plus 4. And we're done there. Part B says, hence write down the coordinate of A and B. Well, let's have a look. B is the turning point, and A is where it cuts the y-axis. So it cuts the y-axis when x equals 0, the other letter. So we have got y equals x minus 2 squared plus 4. So when x is 0, that gives me minus 2 squared plus 4. 2 2s is 4, plus 4 is 8. Or you could have got it from the original equation. That's the last number because that's 0, 0, 8. So the coordinate for A is 0 and 8. For B is even easier. The turning point, you have the turning point when you complete the square. It is in here. And what it is you change the sign on this because you want to make this 0. So that becomes 2, because 2 minus 2 is 0. And the other number just stays the same, 4, 2, 4. And we're done there. National 5 Maths 2024 exams last minute calculator paper question 9. Solve 3x squared minus 14x plus 5 equals 0. So that's called a quadratic. Now if you're in a non-calculator paper, you'll be looking to see if it factorizes. But since we're in the calculator paper and this is correct to 1 decimal place, it's the quadratic formula. So check the start of the exam paper. If you do that, you'll get a formula that looks like this. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now make sure you copy that down exact. And that works when it says x squared x number equals 0. If it's not in that form, change it. So identify my a, b, c. A is 3, the number in front of x squared. B is minus 14 and c is 5. So I just substitute in. So that gives me minus 14, watch out for double minuses, plus or minus the square root of minus 14 squared minus 4 times 3 times 5 all over 2 times 3. You usually get a mark for the substitution. So now I usually work it a bit under the square root sign first because that's called a discriminant and you get a mark for getting that bit correct. So using my calculator, got minus 14 squared, so make sure it's in brackets. If you're putting the minus in, I'll just ignore the brackets. Minus bracket 4 times 3 times 5, that's 136. So I've got x equals minus 14, that's plus 14, plus or minus root 136, all over 2 3s is 6. So now we can work it out as two separate sums. X equals 14 plus root 136 over 6, and x equals 14 minus root 136 over 6. So two separate sums, always write down the unrounded answers first before you round. 14 plus root 136 equals that, divide by 6, 4.2769. I just put dot 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 there. And then 14 minus root 136 divided by 6 is 0.389 and a bunch of other numbers. And then to 1 decimal place, that's 4.3. And that one is 0.4. And we're done there. Is this triangle right angled? So this is the converse of Pythagoras. We need to do this in a nice certain way, otherwise you don't get marks. You keep it all separately. If you start off by saying 23 squared plus 32 squared equals 45 squared, you will lose marks. Do not do that, keep it separate. So here's how I'm going to do this one. Nice little line. I've got 23 and 32. So 23 squared plus 32 squared on this side. And the other side's 45. 45 squared. Work out these separate answers. So 23 squared plus 32 squared is 1553. 45 squared is 2025. No need to square root. So we get two different answers. If we've got the same answer, it'd be right angled. If we get different answers, it'd be not right angled. So we now just say that. Well, 23 squared plus 32 squared does not equal 45 squared. So by the converse of Pythagoras, or just by Pythagoras would be fine. The triangle is not right angled. Now, with this type of question, you're often asked, not only is it right angled, but is this directly north of this or something like that? And then you have to answer that question too. So therefore, yes, no. But for this one, it's just right angled. Question 11, find the size of the largest angle in question 10's triangle. So remember, we had the triangle that looked like this, but it wasn't right angled, it was off a bit. And the numbers were 45, 32, and 23. Now, we can't use SOHCAHTOA because it's not a right angle triangle. So we're using the sine rule of the cosine rule. So we'll try to find this angle because that's the largest one. So My rule for this is, if you've got three sides and you find an angle, you know it's a cosine rule, otherwise it's a sine rule. Or if you've got two sides and you're trying to find a third side, it's a cosine rule. So something with three sides, it's a cosine rule, otherwise it's a sine rule. So the cosine rule from the start of the exam paper says cos A equals b squared plus c squared minus a squared all over 2bc. So what is my A, B and C? Well, A is my angle, so that's my A, and my B and C are either side. So subbing in, I get 32 squared plus 23 squared minus 45 squared all over 2 times 32 times 23. 32 squared plus 23 squared minus 45 squared, that's minus 472 on the top. 2 times 32 times 23 is 1472. No need to simplify because we're going to find the angle. So that's cos A, so we do the inverse cos of 472 over 1472. We just do the positive version. That gives me 71.3 degrees. Using a cast diagram then, cos is negative, so it's S and T. Now, I'm only going to pick one. It's a triangle, so it can't be T because that's 180 plus. So it'd be over 180 is too big. So I'm picking 180 minus. So it's 180 minus 71.3, which is 108.7 degrees. And we're done there. Okay, last minute, National 5 Maths 2024, Paper 2, Question 12. The number of past papers completed by revising students is 3, 4, 5, 7, 11. Find the mean and standard deviation. And then there's a statement. The mean was 4 for history students, standard deviation 6. Speak to comparisons. So let's go with the mean and standard deviation. So start of the exam paper, there's two formulas for standard deviation. And the one I use is standard deviation equals the square root of the sum of x minus x bar squared over n minus 1. This formula, I always just remember this table. We write x, and then the top of it, x minus x bar, and then x minus x bar squared. Because then if we add up all the x minus x bar squared, we'll have a total for the top, and we'll just divide by n minus 1, one less for the number of numbers. So what have we got? 3, 4, 5, 7, 11. 3, 4, 5, 7, and 11. Straight away add the numbers up. 3 plus 4 plus 5, 5 plus 7 plus 11 is 30. So the mean, which is our x bar, is 30 divided by 1, 2, 3, 4, 5, that's 6. So then in the middle you do each number take away 6. So 3 take away 6 is minus 3, 4 take away 6 is minus 2, 5 take away 6 is minus 1, 7 take away 6 is 1, and then 11 take away 6 is 5. And then in the last column we square the numbers. 3 3s is 9, 2 2s is 4, 1 1s is 1, then 25. Notice the minuses become pluses, so it's just a minus is a plus. So you just drop the minus. 9 plus 4 plus 1 plus 1 and 25 makes 40. So standard deviation is the square root of 40 over n minus 1 was 1, 2, 3, 4, 5, so 4 numbers. Square root, open bracket, 40 divided by 4, close bracket, 3.16. So now we have to make two comments. So it says the mean was 4 for history students and the standard deviation was 6. This is about past papers they studied. So 4 and 6. So for history, we've got 4 and 6. And for maths, we've got 6 and 3.16. So for part B, well, that's the mean, and that's the standard deviation. So comparing the mean, on average, more maths papers were done, and that's because 6 is bigger than 3.16. And then looking at our consistency, standard deviation is 3.16 against 6. So the number of history papers done by students was more varied. I always use varied because then I can just say it's a bigger number minus the bigger number, 6, is bigger than 3.16. And I'm done there. Question 13, the area of a sector is 12. Calculate the arc length. Well, that's a hard one, area to arc length. Now let's see what information we've got. We've got the area, we've got an angle. So I suppose we're going to need this radius. So we're going to have to work backwards from area to get the radius, and then work forwards to get the arc length. So let's call that the radius. First of all, we're going to find the diameter. So area is equal to angle over 360 times pi r squared. But we're given the area, that's 12. We're given the angle, and we're told we know pi r squared. So we need to work backwards. Now, the easy way to think of this is what you divide by is what end up what you times by, and then the stuff on the top goes on the bottom of the division. So r squared, in other words, is 12 times the 360 divided by 55 times pi. And r is going to be the square root of all that. So I'll just do it all in one go in the calculator. Open brackets, 12 times 360, close brackets, divide, open brackets, 55 times pi, and we get 5.000, so about 5 centimetres is our radius. And we're done there for the area. Now we have to find the arc length. So arc length, remember, is angle over 360 times pi d. So that was 55 over 360 times pi times 2 5s is 10. And we can just do that in a calculator. 55 divided by 360 times pi times 10 is 4.799, sorry, or about 4.8 centimetres. And we're done there. Basically, that's of our Maths 2024 last minute exam paper for calculator. Question 14. A statue is built from concrete, sphere and cylinder. Both have a radius of 2.5. Find the volume of concrete correct to two significant figures. And then we've got similarity for part B. Let's just do part A. We want the volume. Now it tells us the radius is 2.5. So let me just draw that in. So for a sphere, it's 4/3 pi r cubed. That's at the start of the exam paper. And for a cylinder, you just need to know this one. Area of the base, pi r squared times height. If you ever forget a cylinder, if you look at a cone, just drop the third off a cone and that's a cylinder. So it looks similar. So now we're adding them together. So let's do my sphere. So I've got 4/3 times pi times 2.5 cubed plus pi times 2.5 squared times, now the height is not 13, don't be fooled. It's 13 all the way up. So the height of the cylinder is 13 minus 5. So I do 13 minus 5 at the side. That's equal to 8. So the height is 8. Now you can either do these sums separately, or if you're good with a calculator, brackets plus brackets. As long as you've written it all down, it saves you some time. So bracket 4 divided by 3 times pi times 2.5 to the power of 3. Close my bracket, plus pi times 2.5 squared times 8. Close my bracket again, and I get a final answer of 222.529 or 222.5 centimetres squared. Ask me to round it. Two significant figures, so let's just do that. 1, 2 means I'm cutting here, so it's 220 centimetres squared is my final answer. Okay, part B. A similar statue 1/4 of the height is built. What will be its volume? Okay, let's start with this one then. So if it's a similar statue for part B, we'll kind of have a statue like this. That's drawn. There's my cylinder, and then we'll have a ball on top, I suppose. and we're saying that this height here is 1/4. Well, what does that make? 3.25. So if that height's 1/4, that means that our linear scale factor is equal to 1/4. It tells you in the question. If you don't know that, use the normal way, 3.25 over 13, which would give you 1/4. I'll show you that now. 3.25 over 13. And I'm going small, so I'm going small scale factor. If I try to find something in the big one, it'd be 4/1. So the linear scale factor is that, but we want the volume. So we need a volume scale factor. So we cube that, 1/4 cubed. So that means that the volume of our new shape is just 1/4 cubed times the volume of the old one, which I'll just use the rounded answer, 220. 1/4 to the power of 3 times 220 is 3.4375, or about 3.44 centimetres cubed. And we're done there. It's been quite a maths to do for the whole of National 5 Maths 2024 last minute exam paper from my friend Chris Smith. This has been a fantastic paper. Thanks very much again, Chris, and I hope all the students found that helpful. Take care, stay safe, and goodbye.